Oh, thank you so much, guys. I really appreciate you guys having me today. I am very excited to talk to you guys a little bit about uh, the deeper dark side, not the dark side, but the deeper side of crypto, right? I'm kind of curious in the crowd, who here has some experience with a programming language? If you could just raise your hand. Cool. So I think as like scientists, you're constantly striving to learn something new. And I would say that currently like blockchain and Solidity, which is kind of like one of the core things I'm going to be talking today, is really like a great tool for you guys to accelerate your knowledge and build something really awesome for the community, especially for something like DeSci, which is, I'm a amateur mycologist, and to me, it's a very interesting topic. I by no means call myself a scientist, but I would say that I'm very excited to see what DeSci brings to the world. So my name is Kevin Jones. I work as a developer relations engineer for Edge and Node, working on the graph. If you're familiar with the graph, it's a blockchain layer for API data specifically for your blockchain, for your decentralized applications. But I also work as a developer advocate for Scaffold ETH. So Scaffold ETH is kind of this awesome toolkit that was created by Austin Griffith, and it's now kind of maintained by the Build Guild, or the Biddle Giddle, as you would know. And it's a really cool group of developers that are trying to kind of move the ecosystem forward. This is all my contact info, so I'd love if you guys connect with me. If you guys have questions after I leave today, you're not able to catch me, I'm an open book. I would love to help you guys with anything in your journey to help accelerate the DeSci space. So thank you again for having me. We're going to kind of dive right into it. Today we're going to be talking about Scaffold ETH 2, which is the newest version of Scaffold ETH. So if you're at all, like I said before, have some experience with programming, Solidity is a rather easy language to learn because it has to be very simple on the blockchain in terms of how the EVM works, so the Ethereum virtual machine. But when you first start getting started, it's kind of a little bit of a rabbit hole. You kind of like, oh, one person's using this tool, one person's using this framework. One person, has a blog post that tells you to do it this way, and it's a little bit of a rabbit hole, and you really have to take a lot of time to figure out like what you should use. And Scaffold ETH 2, which is the newest version, both of them, Scaffold ETH 1 and 2, kind of like obfuscate that, so they just let you focus on building and iterating your contract, essentially. So it is an open source project. It is a public good. So we are funded primarily from the Ethereum Foundation. And our focus is really to, again, accelerate developers and onboard them quickly, okay? So Scaffold ETH 2 comes with a lot of tooling, but essentially it comes with Hardhat, which is a kind of like a virtual Ethereum virtual machine that you can run locally. And it allows you to take your contract once you're ready and quickly publish it to a testnet or to the mainnet, Ethereum mainnet. And it also comes with React with Next.js, so that you don't really have to worry about the front end of the application, and you can start iterating and like kind of testing your assumptions of your smart contract that you're building. So if you're going to get started, all you need to really do is go to the GitHub. There are some requirements, so I'm not expecting you guys to follow along because you would need to install these, but if you have Node.js, you need Node version 18 or above. You need Yarn package manager, Yarn is kind of like this way to like wrap everything up in an easy to use way using scripts. And so a lot of that is already kind of like written for you so that you can focus on building your smart contract and focus on building your front end, and you don't have to worry about what all those commands are and like type those out. So Yarn is like this package manager that also has this kind of like not automation, but like orchestration for you built. And then obviously you need Git. So everything is in GitHub. You can just literally just follow this kind of guide, which we're gonna do. I've actually gone ahead and I already checked out the repository for you guys so that we can like kind of get started quickly. I'm using Tmux, which is just like, it keeps my windows in separate, like kind of one single terminal. everything that you do with Scaffold ETH is kind of, there's some back end, obviously. You need to run your hard hat node, and you need to run your front end, and then you need another window to do like your deployments. So you can think of it like hard hat is your smart contract platform, React is like your front end for your web application, and like I said, a lot of that stuff's already written for you. And then this third window is kind of where you do your deploys. So I've kind of already gone ahead and I've checked out the repository, and I've already done the install. So if you just type yarn, it's going to go out and get all the packages that you need, right? So that you can focus on just kind of get going right away. So that's all you need to do is check out the repository, do the yarn install, and then we're ready to kind of get going. So I'm kind of going to do like a demo to show kind of what it looks like. So first, yarn chain is going to spin up a copy of like an Ethereum virtual machine that's running locally. And then it's going to spin up 20 accounts for you that you can kind of like pull from for Ether, so that you can start kind of like testing your smart contract, right? So you're always going to keep that kind of like back-end app up. And then in this front end, we're going to do yarn start. So if you've ever used React, React is just a front-end framework, right? It's your front end. So we have Next.js with Scaffold ETH 2. So we're going to just do yarn start, that's it. And now we're going to have our web server essentially running on localhost 3000. And we're just going to keep that up. So we keep those up so that we can see what's going on with the console. So that you can log stuff on Ethereum, specifically with Hard Hat. You can log like raw data. So if you create a contract, it will show up there on the left. And then obviously we need to keep the front end open because we need to like use it as our tool, right? And also if you have like an error in your front end, like if you're writing JavaScript and you want to create some kind of new UI, that's where you're going to get those errors, right? So in this last window is where we kind of do our deploys. So yarn deploy. And that's going to take essentially a copy of a contract. It comes with like kind of a hello world contract, okay? So let's look at Scaffold ETH. Let's see the secret sauce of Scaffold ETH. So Scaffold ETH is, again, all this stuff is kind of written for you, like so that you can just have a really good starting point and you can get going right away. And so you'll see that the first thing we see is this debug contracts tab here. So when you first go in, what it's doing is essentially it's reading in your contract, and there's already one there. So when I deployed it, it reads in what's called the ABI. So not to get too technical, but the ABI is essentially like the map of how your smart contract works, because when you create a smart contract and it gets compiled and sent to the Ethereum virtual machine, it's not readable. It's not human readable. So you need some way to read it, right? And so that's what the ABI does. The ABI provides this layer or like a map of how you can interact with the smart contract. So the cool thing about Scaffold ETH is it reads in that ABI for you automatically and builds this like beautiful UI for you. So you can kind of focus on like writing your smart contract, making a change, and going from there. So what do we see here? We see there's a read function, we have a write function, we have a way to send a transaction, we have a way to withdraw, that's another write function, and then we have like some variables. So if we define a variable in there, it's going to show up and be available, and then we see our contract on the left, and then we can see if it has a balance or not. So we can instantly see that there's a new way to set a greeting. So we have a greeting, it's here. So if I wanted to set a new one, like DeSciWorld, like this, and hit send, well, you'd think that would work, but I don't have any funds to pay gas, okay? So the first thing you'll learn about Ethereum is it runs on gas. And so gas is kind of like what you pay for your computation. Like if you want to like change the state of the Ethereum virtual machine, you have to pay some gas to do that. If you want to send some value from one person, Alice, to Bob, you have to pay some gas for that, right? It's what makes the Ethereum virtual machine work. So we don't have any gas in our wallet, which leads me to the next part of what I want to tell you is like Scaffold ETH comes with this like burner wallet. You can think of it like an in-browser wallet, like similar to MetaMask, but it's literally session-based. So it's in there, you don't have to worry about MetaMask, you're ready to go and start interacting with your contract. It just doesn't have any ETH in it. So you can just grab this little button here and grab some funds from the faucet. So there's just kind of like, the faucet is all that play ETH that I told you about, so that you don't have to like, worry about like sending the funds from the wallets. You just click that button and it does it. So now we have 1 ETH, now we can do a transaction and say send. And so we can see our variable updated. So we're automatically able to start interacting with our smart contract that's been deployed and go from there. Now, you'll also get a transaction receipt, which is kind of cool. It's just the response, you know, so you can see like, oh, like how much gas did I pay, what booleans were set, stuff like that. And then we can also see the transaction results, stuff like that. So, but this next tab is really useful too. So if you're not a front-end developer, I find I struggle a little bit with the front-end stuff. I'm more of like a back-end guy, but you know, this is a really beautiful UI for you that you can kind of like copy paste from and kind of see how you interact with the Ethereum virtual machine. So this is kind of like your next step. Like first you write your smart contract, then you come in here and start building a UI. Obviously, you probably would not want to call it example UI, and you probably would have some other added functionality, but these are just examples. So I can actually do it here and say, I don't know, Kevin is cool, like this, and hit send. Same thing. It's going to allow me to update the state. And you can see I'm keeping track of like a counter, so how many transactions have been through. Here's my like UI that's automatically adapting, and you can also see that I also sent some value when I did that. So not only did I just update the state of that variable, but I also sent some ETH to this contract. So, you know, smart contracts are like banks, right? You can use them to store value. And so we have, now we have 0.01 ETH in our contract. So we could also withdraw that. You'd think we would just be able to do that, but we can't because we're not the owner of the smart contract. Because we used Hardhat to do our deploys. So Hardhat is actually the owner. So let's take a look at the contract now. Let's kind of go in here and let's kind of do some like iteration on the contract. And let's see what we can do. We're going to do something very simple. We're not going to do anything crazy. Let me close all this stuff and show you where everything is. OK, so when you first go into Scaffold ETH repository, there's like two folders really that you mainly are working in. There's your backend, Hardhat, and there's Next.js. So Next.js is just a framework, JavaScript framework. It's a rather snappy, fast front end, so it's really useful. It's obviously it gets a little more complicated. I would say that's a lot more complicated than the Solidity side, just because Solidity, like I said before, has to be a simple kind of implementation because the functionality of the Ethereum virtual machine is somewhat limited. So we already have a contract. We know that because we deployed it, right? But here it is. It's in the Hardhat contracts folder and then your contract. We can see we like set a license, so we have the MIT license here. We have the version of Solidity that we want to use. By the way, can you guys see that okay? Good? Okay. And then we have like some variables that we're defining that we could see in the UI. We have a string, we have an address called owner, we have a boolean, we have an unsigned integer, which is just like a positive integer essentially, and it's set to 0 at first, and then we have like a mapping that keeps track of the counter, so we store that in a data object essentially. And then we do some stuff like events, but really what I want to show you here is like we do this stuff where we like create ownership of the contract at the time of the deployment. So you see right here we have this constructor. So the constructor, you can think of it like as the initiation. So when the contract is first deployed, that's something that gets set. So we couldn't change the ownership because the ownership was owned by Hardhat. So we might come in and like want to change this so that we could get, let's just kind of remove this so that we can just have an empty constructor, and then let's redeploy, okay? Yarn deploy. It's going to see that there's an error, so it would say like, all right, well like it says address public owner, compilation failed, so we can actually just strip that out. Let's get rid of the owner. You can also get rid of like the modifier. I'm just going to kind of like gut the contract a little bit here so that we can kind of see, you know, what happens when we do this stuff. So let's see if I pulled everything out that I should. Let's try to. We can also do a yarn deploy reset, which is going to like, okay, we still have the withdraw function. We need to get rid of the ownership. We're doing like a modifier here. Now we do that. Reset. We can get rid of the, actually let's just completely withdraw the withdraw function. We're just kind of gutting the contract. I'm getting it more to like a simple state. And then there we go. Oh. So now we're going to see like there's an error. Because we're using Hardhat to do the deploy, the next thing you'll learn is like as you start iterating your contract, you probably might want to do something during a deployment to like, I don't know, like simulate a transaction or like transfer funds, or like if it's a token, you might want to like pass in the arguments to the token on what it's named. So the next thing we're getting is an error about Hardhat. So let's take a look at the Hardhat configuration file, the deployment file, and let's see what's going on. So it's a JavaScript script, and more importantly here, what I want to show you is this is where we do our deployment. So Hardhat uses JavaScript, and we'll see that there's this area here where we actually deploy the contract. And you can see that there's some args that are being passed to the constructor. So the constructor I mentioned before is like this first thing that runs. So we can just get rid of those because I was expecting them earlier because we were using the deployer as the owner. And so that's why we couldn't essentially withdraw funds. So let's save that, and then let's redeploy one more time. So you can kind of see what I'm doing here is I'm getting in this kind of like mode where I'm like, all right, I want to build a smart contract, and this is where I want to start. And you're kind of going here, you're deploying, you're making a change, and then you go over here to the front, and you're seeing, oh, it changed. So I deleted the withdraw function, now it's gone. I deleted the owner variable, so that's gone, right? And you're kind of like doing these like iterations on your smart contract. I'm not going to get crazy on Solidity because I think it's definitely something that you have to kind of go down that rabbit hole if you're, by the way, who here knows Solidity? Does anyone? Cool, all right, we got a couple Solidity devs. But most of you don't. So I want to show you like what I would do if I was learning. So when I first got started and I wanted to start writing smart contracts, I went to Solidity by example. So let's just say we have, these are all examples of how you do different things in Solidity. How you define a variable, how you can do an if-else statement, how you can do a mapping, which is like a data object. Whatever you want to learn to do, you can kind of come in here and you can like just click it. So if I want to learn how to do a mapping, literally this is going to be like the use case of how I would do it, and it kind of explains it. And then on top of that, there's a YouTube channel that the guy's name is Smart Contract Programmer, and he's really, really awesome, and he explains in detail what this example does. So let's just go here to the first app. So we have this first app, and we have, what this is doing is, it's very simple. It's just an unsigned integer, which is a variable, and it's giving us 3 functions to increment, decrement, or get the function. So let's just say we wanted to see how this works. We could just grab it, come over here to our smart contract. Let's close the deploy script, and let's just kind of like paste it in right below the constructor. I'll just do best practices. It's better to put the variables at the top so that you know what's going on and it's easy to read. So we have a unsigned integer, and we have it's publicly available, and then we have these new functions that we're going to write. So we're going to save that and then just deploy our change. So you can literally just copy paste from Solidity by example and drop that in, and then we can see in our front end that that should kind of, here, there it goes. So now we have these new functions. So the UI is adapting to our Solidity contract. So we can say increments, 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 right? So we're changing those, we're sending transactions and simulating what our contract would do when we deploy it. So it's kind of this iteration, you know, make a change, test it in the UI, and go like that. You can also like simulate another user. So you could do something like this where we say new incognito window, go to localhost 3000, and now we get a new burner wallet. So here we have this kind of like green, pink guy, and then here we have this like kind of darker green, orange guy. So now we have a whole nother user, and we can start kind of simulating. Like maybe this guy wants to write a transaction, says I am green and orange, like this. He can send that, and he's able to, and then you're able to test like access control of your contract, which before we had this access control problem where we couldn't withdraw funds, which is a good thing. But you get the idea. So you can kind of like start, you know, tinkering around with Solidity, deploy your smart contract, and then test your kind of assumptions on how that contract would work for different users, right? And so let's just, I'm going to show you one more thing. So if we go to our smart contract, you'll see here in the top that we're importing a contract from a Hardhat. Hardhat is a you know, the tool, and it allows us to print to the console. But you might want to import more useful contracts. So one of those I always talk about is Open Zeppelin. It's a company, and they write like kind of de facto standard smart contracts that you can use as starting points. So here, like an example would be like if you want to create a token, it's probably an ERC20 token. So they have an example token, and you can just search that, and you can literally just import it here, and then suddenly your contract is also an ERC20. Or if you want to create an NFT project, you can import the ERC721 Open Zeppelin contract. If you want to do 1155, whatever it is. So I'm going to import Ownable. So Ownable is like the de facto way that you do access control if you want to protect certain functions. So I'm just going to show you what that looks like. So we say your contract is ownable like this, right? And we can save that and redeploy again. And then what we'll see is we get that variable back because we're importing ownable, so now we have an owner again. So the owner is still not us here. It's the hard hat account. So you might want to transfer that later. I'm not going to get too much into detail there, but you can kind of see what I'm doing is I'm kind of messing around, adding some other functions, and I get some new functions that I inherited too. So when you have a smart contract and you import it and then you inherit it, you get everything that comes with that contract. So if I was to go look at this contract online, like it's on GitHub, we would see that it has 2 functions, and we would see that it declares a variable at the time it's deployed, and that's why we see the owner variable, that's why we see this renounce ownership function, and that's why we see a transfer ownership function. So we get access to everything that's inside that other contract. So that's really useful because if you want to build a token or you want to build an NFT or whatever, you can just get access to those functions and then you don't have to reinvent the wheel and write those. Okay, so I don't think we did too much Solidity, and I don't want to scare people away, but it's just a good starting point. But I would say that the next thing that you should focus on if you're a builder, after you've decided, all right, like I know Solidity a decent amount, and by decent amount I mean like you just really have to have a very base knowledge of like how to declare variables, how to create functions, maybe how to do data objects before you get to this next step. But there's a cool, awesome tool called Speedrun Ethereum. Who here heard of Speedrun Ethereum? All right, we got a couple people, sweet. All right, so Speedrun Ethereum is a tool that was also built by Austin Griffith and the Build Guild, which allows people that are onboarding into Ethereum to kind of like test their knowledge. And so if you come here, you can literally just connect your wallet and you can start doing these challenges. So here we have my like profile, and you can say like, oh, okay, I want to deploy an NFT. So we could go through and do this if we wanted to and deploy an NFT. So we click Quest, and there's 2 different examples. There's JavaScript and TypeScript. Currently, these challenges use Scaffold ETH1, but it's pretty much the same as Scaffold ETH2. Scaffold ETH2 is just a little faster, and you can still use Scaffold ETH1. It's fine. And so you'll actually go through and deploy an NFT to testnet, which you could deploy to mainnet if you wanted to as well, if you wanted to pay the gas. But it walks you through kind of what to do. It walks you through how to get gas from the wallet, or get gas from the, funds from the wallet. It walks you through how to change your network, how to start sending funds around, how to mint an NFT. You get to mint these cool little NFTs. And then eventually you can submit your challenge. So you submit it, and then you kind of get like graded. So we can go to my profile here, if I go back and click here. And we can see that I already submitted this challenge. So if the internet works, it looks down. There we go, okay. So we can see that I submitted the challenge earlier. I actually did this like a couple days ago for some people and showed them how to do it. And it was accepted, and it's all automated. So, and then we have access to our code, so we can see our smart contract that we deployed. Here's the NFT. We can see like that I use ownable, stuff like that. So it's really cool. It's a really cool tool. And then we also have the front-end demo that we did too. So innocent pullage, so we can see if we connect our wallet, which we already have connected. I have some NFTs in there as well. So this was all done with Scaffold ETH, all built with Scaffold ETH. And so, like I said, it's a real cool tool to get started. Eventually, if you do get into Speedrun Ethereum and you go through these challenges, after the 3rd challenge, you actually get invited to the Build Guild. So if you're a developer, it's a really cool group of developers that help kind of prop up that ecosystem. And you can actually, like, if you start creating your own builds or provide value to the Build Guild, you can actually get a stream as well. So that's kind of like an added bonus if you're a developer. You can see that there's people that have streams. I'm one of them. And we see that we're actually streaming ETH to developers that are building the ecosystem or tools around that. So maybe you want to build a, I don't know, a DeSci, a decentralized science app, you know, on top of Scaffold ETH or some kind of like added package. Like that would be really cool, right? Like something that can be reused as a public good, right? Because the Build Guild is a very public good company. So this is kind of like all the contact information for Scaffold ETH. So Scaffold ETH is available just by searching Google. But if you want to get on like the Telegram channel will give you access to all the other developers. There's over 2,000 developers working in the Build Guild. But there's about, I would say, more or less, you know, a little less active, probably more in the realm of like hundreds, but still, that's a pretty big community, especially for if you're a developer and you're just getting started writing smart contracts, and kind of go from there. I also want to talk just briefly about the graph. Who here is familiar with the graph or has heard the graph? Okay, cool. So the graph is a really cool tool as well, and I think it really applies to decentralized science, because one of the problems with the blockchain right now is that the blockchain is really incentivized for writing data, and it not really is very incentivized for reading data. And so one of the problems that we see as far as like why the graph was created is that that data needs some kind of like middle layer to be able to provide an API. So if you want to like get data from the blockchain, it's kind of difficult to do. You literally have to like make a RPC query, and it's rather slow, and you have to query for a specific amount of information. You can't really do this kind of like broad query to get like all the data that you want in one query, so you end up having to loop over things. And so what the graph provides is an API layer, so utilizing what's called GraphQL for your blockchain data. So if you have a smart contract that you write, you can essentially create what's called a subgraph that indexes that data and stores it on the graph's network. And it's a decentralized protocol. So you can provide a decentralized data structure for your decentralized application on the blockchain that others can use. So I think that really helps for like accelerating something like DeSci, especially if you're making a public good for science, where you want to create, I don't know, like I'll relate it to mycology just because that's my interest right now. Let's say you wanted to create a data model that, you know, calculated all of the species of a mushroom in one particular continent. And you wanted to allow people to add to that count, like maybe every time that they visually see one and take a picture, and then that increases, and you want to provide that in like a data API endpoint. You could create some kind of like tool on the blockchain that keeps track of this stuff, and then you could also create this kind of like API layer. And so that's a decentralized API data layer, so anyone can consume it, right? So if you're building a decentralized science application, you can literally utilize the work that someone's already done, which is going to greatly accelerate your value, right, of your product or what you're working on. So yeah, so that's pretty much it. I would love to like answer questions. I didn't really get too technical just because I think that the learning curve for Solidity is definitely one that you have to kind of go through and like iterate and start building. But you can see kind of how easy it is. You don't really need to be a master on the keyboard. You just need to be able to open some terminals, install the requirements, and kind of go from there.